This video is about the QNect early connected model delivery for mandated connection designs, which are dominant on the West Coast. The early connected model is a 3D Tekla model with 100% of the main structural connections already modeled into the model and provided to the fabricator bidders and ultimately to the successful bidder. The early connected model saves time, lowers costs, and reduces carbon. Let me show you an example of an early connected model that will now go to the fabricators for their bidding process. The side plate lateral, shear plates, splice plates, gussets, braces, everything relating to the main structural connections are completed. In the mandated connection designs, the engineer of record specifically details out the connections that they want, and QNect software will mimic those connections, and with our detailing partner, provide 100% of all of the connections, both the lateral and the gravity, into the model. EORs on the West Coast are required by code to design the lateral system, but there is a gravitation towards overriding mandated for gravity connections and for providing the load so the fabricator can design them themselves. More on this in a minute. But let's first take a look at what mandated connections look like before we move to the workflow of the early connected model. Here we see a floor plan where, while there are connections that don't have a detail which apply to the standards that the engineer will specify, there are also details that are specific, FHSC, DR, etc. S15555. These details now show up on the design drawings to mimic. This is for the standard condition. You have the DRI condition or one, the double numbers description, and these are all very specific, and the FH description. As I noted, where engineer of records override the gravity connections, which they're not mandated to do by code, and provide loads, the QNect software can and will be able to optimize those joints accordingly. These gravity details are all either shear forces or shear plus axials. Let me show you an example. Here is a mandated connection for a W24 with 135 kips vertical and 100 kip axial. 18 70-inch bolts are required to perform this calculation and to support it. However, using QNect's software, patented iterative process for optimization, we're actually able to eliminate 10 bolts automatically. There is no mimicking here. QNect just does it automatically with the loads in the model. And while we upsize the bolt diameter, which is a minimal cost, this is a tremendous savings. It's less plate and less weld. However, this particular delivery, we'll talk now about the workflow as it pertains to the mandated and or when connection engineering is required. Let's first address the conventional situation. The blue here is the fabricator has been awarded the job. The designs are often incomplete, pulled early by the general contractor to secure resources. The detailer starts sequence 1 and RFIs start to flow. RFIs continue throughout the job, and RFIs lead to schedule drift and cost overruns. The second challenge is that while the detailers are in sequence 1, sequence 2, 3, 4, and all the way up to the roof or last phase, have issues sitting, waiting to be discovered. Those issues can sit there for weeks, if not months, until the detailer arrives. This further delays the project and further increases the cost overruns. In every steel project, 50% of the time goes into the developing of the model and putting the connections in the model, 50% for shop drawing production. And where delegated connections override mandated connection engineering. Now, the early connected model flips this workflow. It basically moves upstream 50% of the detailing and modeling, and if connection engineering is in play, all of the connection engineering. And while there's a lot of work starting around 40% DD, round tripping with engineer of record, identifying issues for the entire building using the QNX software to identify and solve issues early, ultimately, the early connected model is delivered to the bidders at time of bid and handed over to the steel fabricator to continue the 50% of the detailing shop drawing production. As you can see visually, this is a huge difference in time. More specifically, 2 weeks of the conventional detailing is to develop the model, leaving 10 weeks in a 12-week schedule. Half of that went upstream, so you've saved 5 weeks. You're now at 7. And because the RFIs have been solved early, at least about 70%, you see the schedule drift mitigated probably down to 1 week. So on the 16-week schedule, we can in fact see and achieve about a 10-week difference with the early connected model delivery versus conventional late connected model. Let's move to cost. There are 2 big buckets of cost savings. The first one is the fact that this model has all of the connections in it and reduces the uncertainty for the bidders, thereby reducing their risk premium. We see more uniform bids and lower bids. The second big bucket is that since we've solved about 70% of these issues early, post-award, RFIs dramatically drop and similarly change orders. To that end, let me provide you a quote from Alan Paul, Senior VP at AECOM Tishman, who is a huge proponent of this delivery. He says, by getting the models connected early, the bids were faster, closer, more accurate, and contractors had better information. Change orders, this is the second big bucket of savings. We're running 10 to 20%, we're closer to 5. With a connected model, we hit our schedule, reduced extras, and saved at least 2 months off a job. The early connected model saves time, saves costs. And because we deliver the mill order ready model, the material is the exact length, not centerline to centerline. And so we see savings of anywhere from 2 to 9% of the total steel, which reduces carbon. For more information or for a presentation for your company, please contact us at qnec.com. Thank you. Look forward to working with you.